Keeping the water away. New approaches to flood control. Recently, winter floods on the rivers of Central Europe have been among the worst for 600 to 700 years, and dams and dikes, protective seawalls, have failed to solve the problem. Traditionally, river engineers have tried to get rid of the water quickly, draining it off the land and down to the sea in rivers re-engineered as high-performance drains. But however high they build the artificial riverbanks, the floods keep coming back. And when they come, they seem to be worse than ever. B. Engineers are now turning to a different plan, to sap the water's destructive strength by dispersing it into fields, forgotten lakes and floodplains. They are reviving river bends and marshes to curb the flow, and even plugging city drains to encourage floodwater to use other means to go underground. Back in the days when rivers took a winding path to the sea, floodwaters lost force and volume while meandering across floodplains and inland deltas. But today, the water tends to have a direct passage to the sea. This means that when it rains in the uplands, the water comes down all at once. C. Worse, when the floodplains are closed off, the river's flow downstream becomes more violent and uncontrollable. By turning complex river systems into the simple mechanics of a water pipe, engineers have often created danger where they promised safety. The Rhine, Europe's most engineered river, is a good example. For a long time, engineers have erased its backwaters and cut it off from its floodplain. The aim was partly to improve navigation and partly to speed floodwaters out of the Alps and down to the North Sea. Now, when it rains hard in the Alps, the peak flows from several branches of the Rhine coincide where once they arrived separately. And with 4/5 of the lower Rhine's floodplain barricaded, the waters rise. The result is more frequent flooding and greater damage. The same thing has happened in the US on the Mississippi River, which drains the world's second largest river catchment into the Gulf Mexico. Despite some $7 billion spent over the last century on levees, embankments, the situation is growing worse. D. Specialists in water control now say that a new approach is needed, one which takes the whole landscape into consideration. To help keep London's feet dry, the UK Environment Agency is re-flooding 10 square kilometres of the ancient floodplain of the River Thames outside Oxford. Nearer to London, it has spent £100 million creating new wetlands and a relief channel across 16 kilometres of floodplain. Similar ideas are being tested in Austria, in one of Europe's largest river restorations to date. The engineers calculate that the restored floodplain of the Drava River can now store up to 10 million cubic meters of floodwater and slow down storm surges coming out of the Alps by more than an hour, protecting towns not only in Austria but as far downstream as Slovenia and Croatia. E. The Dutch, for whom preventing floods is a matter of survival, have gone furthest. This nation, built largely on drained marshes and seabed, has had several shocks in the last 2 decades when very large numbers of people have had to be evacuated. Since that time, the Dutch have broken one of their most enduring national stereotypes by allowing engineers to punch holes in dikes. They plan to return up to 1/6 of the country to its former waterlogged state in order to better protect the rest. F. Water use in cities also needs to change. At the moment, cities seem designed to create floods. They are concreted and paved so that rains flow quickly into rivers. A new breed of soft engineers wants cities to become porous. Berlin is one place where this is being done. Tough new rules for new developments mean that drains will be prevented from becoming overloaded after heavy rains. Architects of new urban buildings are diverting rainwater from the roofs for use in toilets and the irrigation of roof gardens, while water falling onto the ground is collected in ponds or passes underground through porous paving.
One high-tech urban development can store a sixth of its annual rainfall and reuse most of the rest. G. Could this be expanded to protect a whole city? The best case could be Los Angeles. With non-porous surfaces covering 70% of the city, drainage is a huge challenge. Billions of dollars have been spent digging huge drains and concreting riverbeds, but many communities still flood regularly. Meanwhile, this desert city ships water from hundreds of kilometers away to fill its taps and swimming pools. Los Angeles has recently launched a new scheme to utilize floodwater in the Sun Valley section of the city. The plan is to catch the rain that falls on thousands of driveways, parking lots, and rooftops in the valley. Trees will soak up water from parking lots. Houses and public buildings will capture roof water to irrigate gardens and parks. And road drains will empty into old gravel pits to recharge the city's underground water reserve. Result: less flooding and more water for the city. It may sound expensive until we realize how much is spent trying to drain cities and protect areas from flooding, and how little this method achieves.